if we've got the power and we have the time, can we calculate the Q? This is the main way that our body cools itself off. Less energetic state, which is the liquid sweat, into a more energetic state, which is the gas.
That's today on High Peak Education.
When a runner runs, he or she produces heat energy. Assume the runner has a mass of 70 kilograms and is mainly made of water. The runner generates heat at a rate of 1,200 watts and runs for 30 minutes. Show the thermal energy generated is 2.2 times 10 to the 6 joules. Calculate the temperature rise of the runner, that's water, assuming no energy loss. This temperature rise would be dangerous. Outline 3 ways in which the heat energy is lost by the runner. Roman numeral lowercase 4. Some energy is lost as evaporation of sweat. Describe in terms of energy of molecules how evaporation causes cooling. 5. The percentage of energy lost by sweating is about 50%. The specific latent heat of vaporization of sweat is 2.26 times 10 to the 6 joules per kilogram. Use this information to calculate the mass evaporated from the runner. Date and explain 2 factors which affect the rate at which sweat is evaporated from the runner. So here we go. Runner produces heat energy, mass of 70 kilograms. Next, it says the runner generates heat at a rate of 1,200 watts. So again, that's power, right? Capital P. Because they're specifically talking about generating heat and we're given the time, I'm going to suggest let's also put that equal to Q over delta T. Now, the time is given as 30 minutes, but we want to probably keep things in minutes.
Probably not.
I'm going to say no, because we probably want to convert it to what? Yeah, let's convert to seconds. 60 minutes in an hour, 60 seconds in a minute. Half of that would be 1,800 seconds. Now, we should be able to do the calculation for number 1 without too much difficulty. Show the thermal energy generated is 2.2 times 10 to the 6 joules. Well, if we've got the power and we have the time, can we calculate the Q? That's the heat energy, thermal energy generated.
Yeah, absolutely.
If Q over delta T equals P, then how can we solve for Q?
You can do Q equals delta T times P.
Perfect. And that's pretty easy. Put the numbers in, right? What is that? 1,800 seconds times what?
1,800 watts.
So that's capital J for joules, and put a box around that. All right. Then let's do Roman numeral 2. It says calculate the temperature rise, assuming no energy loss otherwise. And we're going to use 4,200. That means the temperature rise is all going to be due to what?
The change in just the specific heat capacity and mass.
Exactly. Let's write Q equals MC delta T. So how can we solve for the temperature rise?
Well, we could do Q over MC.
Exactly. Equals delta T.
2.2 times 10⁶ over, what was it, 70 kilograms?
Yep, and then the C was 4,200, and that'd be joules per kilogram Kelvin. 7.48. And nice job using the approximately symbol. I'm a fan of that when you're doing a calculation like this. You can do degrees Celsius or Kelvin, either way. That's about 13.5 degrees Fahrenheit. Which if you think about it, that'd be like my body temperature going from like 98.6 to like 110 degrees Celsius.
Hey, thanks for watching our content here in High Peak Education. Please hit those comments down below this video and let us know what other kinds of videos do you want us to make. Thanks for your engagement. We appreciate it. Let's get back to today's video.
Let's go for Roman numeral 3. This temperature rise would be dangerous. Outline 3 ways in which heat energy is lost by the runner. What's one way that they're talking about below that heat is lost by the runner?
Well, of course, sweat. Your body excretes liquid,
Yeah, exactly right.
which then evaporates. You're giving off thermal energy from your body, which is a hotter body of mass, to the surrounding air. Which is
Yeah. So this is probably the main way. This is the main way that our body cools itself off. Another question, does our blood temperature and our body temperature actually still increase? Right, our body temperature and blood temperature does still increase a little bit. Any other things we can think about?
I mean, I guess even without sweat, your body is still going to radiate heat through your skin. Just because your body's hot, the surrounding air is cooler, the heat is naturally going to radiate out of your body.
Exactly. I love that. And we can actually give a reason for that, because our body will be at a higher temperature. So the radiation rate will increase due to the larger between our skin, the air temperature. So let's talk through 4. So the heat energy from the body is going to go into the what? So it's going to go mostly into the sweat, which is like water, and go from a less energetic state, which is the liquid sweat, into a more energetic state, which is the gas. So you want to basically say the energy goes out of your body into the sweat, causes the phase change, and thus your body has lost heat energy, so it cools itself off. Number 5, the percentage of energy lost by sweating is around 50%. There's the latent heat. So basically what I would do, I would take Q times 50%, which is Q times 0.5. Then I would divide that by the latent heat of sweat, and then you could get the mass of sweat. And then lastly, number 6, explain 2 factors which affect the rate at which the sweat is evaporated from the runner. We've already kind of discussed this a little bit in number 3. So first of all, is the temperature difference between my body and the environment going to be important for radiation?
Yes.
That's going to be important. So we're already going to talk about that. But also, what's going to be the difference between running at 50 degrees Fahrenheit, let's say, in the Arizona desert versus 50 degrees Fahrenheit, let's say, in Miami in the summer? But here's what I'm thinking. Which is usually going to have more moisture in the air, Arizona or Florida?
Florida.
Right. Not typically, right? I'm speaking like climatologically speaking. So the reason I bring that to your attention is because, is the sweat going to stay on your body more readily in Florida or Arizona?
In Florida.
Probably, right. Because basically the other thing you want to mention is relative humidity. Don't forget about the effect of relative humidity in the air as the sweat tries to evaporate from your body. So just a quick note, don't not forget that. Okay?